Hi there. Hope you guys are doing great. We're going to look at section 10.1 right now, which is about exponents. And this section or this book decided to look at negative exponents. So we'll kind of look at what the negative does and what the negative does not do. So just as an introduction, before we start with the notes that I gave you before we left, is we're going to look at something we're going to start with a to the 0. Okay, what is this equal to? And this is something they want you to know in this section. Well, we'll talk about why a to the 0 is equal to 1. Oh, focus. Okay. Later in section 2 or 3. But for right now, anything to the 0 power is equal to 1. So if I had 3xy cubed to the 0, it is equal to 1, all right? And if I had 1,250 to the 0, it's always equal to 1. So just kind of, people see that 0 and they think, well, it's going to be equal to 0. But in this case, when the 0 is an exponent, whatever is inside here, or whatever has that power of 0, is always equal to 1. So that's pretty easy. Also, in this section, they want you to know x to the first, or a to the first, or 3/5 to the first. That power of 1 does not change anything. So x to the first is equal to x. Okay, those two mean the same thing. So we'll be dealing with, so if there is no power here, there's a 1. It also, I'm sorry about that, keeps coming out of focus. All right. Also, here, a to the first is equal to a, and you need to be able to go from here and realize that if you're missing the exponent, it's a 1. Okay, when we start to do our power rules tomorrow. And 3 to the 5th is just 3 to the 5th. All right, so that's the next thing that we'll be talking about in some examples on those notes. And now we may be getting into something new for you guys, and that's a negative exponent. So we're going to talk about a negative exponent and what it's equal to. I've just chosen to use an A, and it doesn't really matter. Now, this negative, what it does and what it does not do, this negative right here. What it does is it changes the position. I kind of covered up the 1 there. The negative exponent changes the position of the base. All right, so here, a to the negative 1 is equal to 1 over a. And you can put that. It's not wrong to put that. It's not wrong to put that power there. It's just really not necessary to put that positive 1. Okay, you can write it either way. So it changes the position. Right now, to begin with, that a was in the numerator, because you can put your whole numbers over 1. And to get rid of that negative exponent, you need to change its position. So it went from the numerator to the denominator, and it became a positive. Once you've changed the position, the negative exponent disappears. So let's go through some examples, and then we'll look at the notes that I passed out before we left for Thanksgiving. So here we have a to the negative 2. Okay. This would be 1 over a squared. Okay. All right, look at another one. 5x to the negative 2. Okay. Now you have to be careful on this, because the 5 has a power of 1. It's just the x that has a power of a negative 2. So there's a difference between this one and that one. This last one that I just wrote down, the 5 is included with the -2. So, but this first one, it's just the x to the -2. So the 5 has a power of 1. Since the power is positive, it will stay where it's at, but the x comes underneath. Okay? And that gives you 5 over x squared. The next one, this one right here, not only is the x being squared because of the parentheses, so is the 5. So this becomes 1 over 5x squared, or 1 over 25x squared. So I brought it underneath, and then I squared both of them and simplified it. All righty. Let's see. Another thing before we start with the notes, just kind of, this is just sort of an introduction, is that what happens if I have, oh, I don't know why I'm stuck on 5s, but that's okay. Let's look at this one. 5x to the -2z over y to the -3. And the instructions would say write without negative exponents. So we're going to go through these individually. There's no parentheses like this one that we did down here. So we'll just be doing them individual. It would be more like this one, where everything has its own power. Now let's look at the 5. The 5 doesn't have an exponent, that's actually written, so it means it has a 1. It's 5 to the first. Because it's 5 to the positive 1, it's going to stay. So the 5 stays. I have enough room to write it on the side here. Okay, I'm going to draw my bar. I wanted you to see that there are times when something is moved up, because in all of these, we've always been moving something to the denominator. Okay, let's look at the x to the -2. Well, it has a negative exponent, so we will move it down and make it x squared. So when you do change the position, the negative disappears. The z has a power of a positive 1. Because of that, the z will stay where it's at in the numerator. Now we still have the y to the -3. The y does have a negative exponent. Because it's negative, that negative exponent changes positions with the base being a y. So this right here, the y will come to the numerator, and it will become a positive exponent when it does. Now, this isn't wrong if you were to write it like this, but normally we like the variables in alphabetical order. So, this looks a little more conventional, I suppose, but that would be the answer. So you take these individually, moving them from numerator to denominator, denominator to numerator. When they have a negative exponent, you move them, but once you've moved them, the negative disappears. So that's what the negative exponent does. It's not really too bad. What it does not do is it does not change the sign on the answer. So here students have students want to, -a, they want to make this like that. All right. So the negative does not change the sign. The negative exponent changes its position. What does change the sign is the number here. That's the only thing that has, I guess, the power to change the sign. So in other words, let me just get another sheet of paper here. Hopefully it's in focus. I don't think so. All right. There we go. So in other words, if I had 4 to the negative, well, sure, 4 to the -2. I don't need the parentheses if I'm not going to put a variable around it. So let's just do, yes, I do. All right, something like this. All right, so this has nothing to do with the negative in front or the positive. This negative will change the position of the -4. Okay. So here I could rewrite this. Okay. I changed its position. It's still a negative. What can change it to a positive is if this is even. Okay. That's what changes the sign. Because it is even, it will become a positive. So this answer is 1/16. So I squared the 4. Because it's even, that becomes a positive. And then 4 times 4 is 16. Okay. So the only thing that can change the sign on it is if this is an even power, but it does need to be in the parentheses. Okay. Because if I had a -4 squared, I'm not going to put the negative on there. That actually is a -16. You need the parentheses. Whoops. You need the parentheses in order for it to be a +16. So there's a lot of little things to watch for. All right, so this would be a -16. This would be a +16. And then if I were to put a -2, the negative changes the position. Okay. But because it doesn't have parentheses, this negative is not included in the squaring. So this would actually be a negative. It stays, and then you have 4 squared. That changed the position. So -1/16. Okay. All right. So let's see. One other thing before we start. Fractions. 2/5 to the -3. Something like this. What do you do if you have a fraction? Well, this changes the position on what's in the parentheses. So this will change its position, and this will become 5/2 cubed. Okay. All right. So here we'll have 125/8. So you switch them both. All right. When you have inside the parentheses, that comes to the denominator, the 5 will come up to the numerator. And then you can cube it. You can, the order here actually does not matter. You could cube it and then flip it, or flip and then cube it. Okay, you'll get the same answer. So the order there doesn't matter. Probably the only thing that might give you guys some issues will be these negatives here. Just kind of have to watch it because we've talked about those before. So, all right. Well, what we're going to do now is we're going to look at those notes that I handed out before Thanksgiving. And if you did not get those, that's fine. All right. Let's just go ahead and just get started with some of the problems themselves and just kind of a review of everything that we did. And then this section's done and I can post it. All right. So let's look at number 5. All right. We have 8 to the 0. So you'll just need to remember that this does not equal 0. It's, it's just kind of hard. You see that 0 and you think, oh, anything, like 8 times 0 is 0, but not 8 to the 0. So this is actually going to be equal to 1. Anything to the 0 power is 1. But anything to the first power stays the same. So this statement right here, 37.2. Okay. Those are equal to each other. Anything to the first power is the base itself. All right. Now in number 7, 8, 9, and 10, they're asking you, what if you substituted in this value for the x, what does it equal? Well, if I substitute 46 into x to the first, I get 46 to the first, which is just 46. Obviously, you don't need to go through all those steps when you're doing it. You could probably just look at it. Number 8. Okay. Unfocus there. There you go, focus. Now, they want you to, what if you were to put 7 into here and take it to the 0 power? Well, you can obviously, 6 times 7 is 42, minus 1 is 41. Anything to the 0 power is 1. So it really doesn't even matter what you get when you put 6 times 7 in. All right, that doesn't really matter because I know that no matter what number I have to a 0 power is equal to 1. So you can save yourself a little bit of time, even if you did take 6 times 7 minus 1. But just remember that to save yourself some time, any number, no matter what it happened to be, to a 0 power is 1. Now be careful of number 9, because on number 9, the 2 is not to the 0 power because there's no parentheses around it. See, here on number 8, you had the parentheses to a 0 power. So it was 1, but this is 2 to the first times x to the 0. All righty. Now, again, you do powers before you multiply. So if you were to put the 4 in right here, it would be 2 times 4 to the 0 plus 9. Okay, I'm just going through all of the steps. 4 to the 0 is a 1. Okay, notice the 2 is not a part of the 0 power. This means 2 times x to that power. So here we've got 4 to the 0, because doing your PEMDAS, you do exponents first, and then you do your multiplication. So we have 4 to the 0 is 1. Now we do our multiplication, and then you add. So there's the answer on number 9. All righty. So just kind of be aware that you have to do this power, no matter what it had been, you would have done it first. X squared, you would have taken 4 squared times, which would give you 16 times the 2. So you do the power before you multiply it by 2. All right. Let's look at number 10. Again, it's a little different. You're going to put the 13 in. All right, and it looks pretty much just like, it's a combination probably of number 9 and number 7. But you put the 13 in. 4 times 13 to the 0 minus 2. Following our rules of PEMDAS, we'll do the parentheses. Within the parentheses, we're going to do the exponent before you multiply it by the 4. So this 13 to the 0 power is 1. Then you multiply. Now you do your parentheses, and you end up with 2. This is to kind of follow the order that we've done before with the PEMDAS. You guys will be great. Okay, so, and again, if you don't have these notes, it's not that hard to copy those down. All right. Let's look at the back side of this, right here. Refocus. So they want you to write an equivalent expression with a positive exponent, then simplify if possible. So looking at number 11, we have 7 to the negative 3. So that negative exponent changes its position only. It won't change the sign. It won't make it a negative 7. It actually just changes the position of the 7. So right now, the 7's in the numerator. It's over 1. So I'm going to put this 1 over 7 cubed. All right. So, and again, you just brought it down, and it doesn't matter the order that you do this. You could actually cube the 7 first and then flip it, or flip that and then cube it. So 2, 4, 3. Okay. So I just took 7 cubed and, you know, try, oh, sorry, 343, not 243. My fault. Didn't think, okay. Just remember that it's not 21. You know, it's 7 times 7 times 7. So just kind of watch that. Make sure you don't take 7 times 3. It's not a multiplication. It tells you how many 7s you're multiplying together. So there's your answer. Let's look at this one. Oh, this one isn't as quite as bad. We're going to have 9 to the negative 1. So the that negative exponent will change the position. If it's in the numerator, it goes to the denominator. If it's in the denominator, it comes up to the numerator. So here in this case, this will be 1 over 9 to the first. Just to save yourself some time, you don't need that positive 1. Remember, there you go. Simplifying it further, 1/9. So when you do change its position, the negative disappears. So don't forget that. Okay, number 13. Here we have a negative y to the negative 2. So I know I'll be changing the position, but that's even. And because it's even, that will change that sign. And the reason it's changing that sign is, first off, it's even, and you have the parentheses around it, which means that the negative is also being squared. All right, so here, this 2 gets rid of the negative, and this negative exponent puts it in the denominator. So we'll have 1 over, it'll be, I'm not sure, y squared. Okay, I did a bunch of steps there, but here the 2, because if that had been a 3, the negative stays. All right, so maybe I'll do a sample of that real quick. And the negative, this negative here, put it underneath. This 2 got rid of the negative sign. Now, what if I would have had this? Then it will go underneath. You've got the cubed, but because it was a cubed, that negative stays. Now, where do you put the negative? It doesn't really matter. You can put it up here in the numerator. You could put it right here or down here. Let's just put it right up here with the numerator. Okay. It doesn't matter where you put your negative, but the negative stayed. That negative stayed because it's odd. This negative left because it's even. Okay. So whether it's positive or negative depends upon the number value, not the negative in front of the exponent. All that does is change positions. All right, doing great. Just kind of go through these and be great. Done. This one, 14. The A has a positive 1. So the A is not a part of the negative 4, just the B. You'd have to have parentheses around it in order for it to be a part of the negative 4. So the A stays, and the B comes to the denominator and becomes a positive. When you do change the position, you drop the negative. You've done the job of the negative. Okay. Let's look at 15. The 8 stays, and the B comes down. And oh, sorry, yeah, it's a negative 3. And it becomes a positive. Now let's look at 16. It's in the denominator. It's got a negative exponent, so it will change position. It will come up to the numerator. And then once you've changed the position, you drop that negative exponent. All right, 17. M cubed over n to the negative 4. Again, the m cubed stays, and the n comes up and becomes positive. Perfect. 18. The a squared stays. It has a positive exponent. The only time you change position is when you have a negative exponent. I could draw my fraction bar. The b to the fourth will come underneath. And when you do change the position, you drop the negative. And the c comes up and becomes c to the first. So great. So again, you're just changing positions. Number 19, you've got that negative and they're in parentheses. So the negative is going to flip. It takes the reciprocal of the 7/6. So that negative means the 7 goes underneath and the 6 also changes. Everything changes position in the parentheses. So that gives you 6/7. Okay, I did the job of the negative, so so it's gone. And now you square what's in the parentheses. So this will become 36 over 49. And again, resist the temptation to make that 12 over 14. Try not to do that. So you get 36 over 49 as your answer. So you took the reciprocal, you flipped it, both of them, 7 underneath, 6 in the numerator, and then I squared them after I took care of the negatives. Okay, number 21, we're going to reverse this. Write an equivalent expression using a negative exponent. And notice they don't say simplify. So you'll be aware of that when you're doing your Pearson, that you don't go ahead and take 2 to the 4th. Actually, I'm not really sure if they want you to. You have to look at this, but I think we'll just leave it. So 2, this is underneath. Those two mean the same thing. All right, so we're just kind of reversing our idea. So 2 to the negative 4 means this. So they want you to write it using negative exponents. Bring it up and make it negative. And this is going to help us when we start multiplying our bases together. This right here is 3x to the negative 5. Those two statements mean the same. So they want you to be able to go here and reverse the process and write it with a negative exponent. So you brought it up, but you had to put a negative there. And that negative told you that you changed the position. And 22, c to the negative 8. These two mean the same thing. Okay, so, all righty. Now, I also had, for some of you, if you need some extra practice, you also grabbed one of these. Now, this first page, this was stapled together. This was the group that was stapled together. Here's some more samples if you need it. And at the bottom are the answers, just to kind of help you out if you need some more samples to look at. All right. Okay, that's all for this lesson right here. And you know, it just takes some practice and getting used to. I think you guys will be great. Again, let me know if you have any questions. All right. Thank you. And I will stop.